what this digital transformation mandate is about is a fundamental issue of corporate survival, whether you want to be on the train or whether you want to be on the tracks.
We're trying to think about new visions, new models, new methods, and how we use technology, including AI, to enable our people to create value and to deliver results for our customers and for the company.
The potential for the ways that sort of science and automation can change the entire world is really mind-bending. The options are limitless.
You need to understand the data you have available is a core product that you have. It is value. And in order to realize that value, you need to understand how to leverage that.
This is a very large-scale effort. It's extraordinarily challenging. We're working with some of the largest companies in the world, and we're making the world a better place.
Hi, everyone. Welcome to C3 Generative AI for Utilities webinar today. My name is Guo Ang. I'm an outbound product manager at C3 AI, and I will be your moderator today. I'm excited to be joined by the two core members of C3 Generative AI product, Louis Poirier, Vice President of AI ML, and Michael Haynes, our lead product manager. Louis will share C3 AI's approach and experiences in utilities, our unique approach to generative AI for utilities, and several use cases. After that, Michael will have demo a few of these use cases for you. Before we get started, I do want to point out that we have a Q&A window. If you have any questions during the presentation, feel free to send them in. Our team will either have answered them through the chat or at the live Q&A session at the end. Thank you all again for joining us. And with that, I would hand it over to Louis.
Thank you very much for the introduction. I'm very excited to be here, talking about C3 AI and what we do for utilities, and how generative AI actually enables us to go even further. So my name is Louis Poirier. I'm VP of AI and ML at C3. I've been at the company since 2012. So this topic of utilities is actually pretty close to my heart because that's what made me join the company. That's what we were doing at the very beginning, and that we have continued to do for the past 14 years. Mostly in data science and machine learning engineering. I've been taking care of generative AI for the past year, and we'll talk about those topics. When we talk about utilities at C3 AI, we actually look at the entire value chain. So we start from the customer operations, driving energy efficiency solutions, making sure that utilities are able to connect with their millions of customers, making sure that we can enable those customers to see their bills online, to be able to identify what are opportunities for them to save energy, and make sure that the customer satisfaction of the utilities are high. We then climb up the value chain to the advanced metering infrastructure, AMI, which is actually one of the first applications that C3 developed along with energy management. And we have been looking for years at and developing solutions with customers on how we can enable all of the value, unlock the value of those smart meters, and through different applications such as fraud detection, for example, identifying non-technical losses. So who is stealing energy in the network at the scale of millions of smart meters. So looking at the 15-minute data, the voltage, different signals that the smart meter is able to give us back, to be able to identify, pinpoint the mode of theft, how much energy is being stolen, and what can be done about it. On the other side of AMI, there's also the smart meter as a device, and that device can fail. And so we have C3 AMI Ops, which is the idea of how can I apply predictive maintenance to advanced metered infrastructure to identify which meters are likely to fail, how I can dispatch the team more efficiently in the field, make sure that those devices are connected to the right transformer, that this is mapped correctly inside of my record system, all of those different aspects. We then climb back one more time and look at the distribution and the transmission. So on those assets, we start looking at very interesting problems related to voltage optimization. The idea that, like in your country, you need to, depending on your country, you need to look at making sure that you are delivering 240 volts or 110 volts, making sure that every single customer is served, that there's no outages, that those outages at least are accounted for through the OMS system, and making sure that like also the network is known, right? There's a typical problem, which is that you have an as designed network and like as operating network, and like those two are different. So how do we reconcile the two? We have done a lot of work also at the substation, transformer, circuit breaker level to try to identify failures, predict those failures also, and basically like make sure that customers are served as much as possible. Finally, on the generation side, we have done a ton of work in predictive maintenance for different generation assets, making sure that the thermal assets, such as the gas plants, coal plants, etc., are using their fossil fuel like as efficiently as possible to burn the least amount of them. Make sure that they're operating also like as much as possible. You don't have to like interrupt the generation of electricity. And finally, like on the renewable side, we have done a lot of work in making sure that the wind farms, for example, are operated as well as they can, making sure that we understand what is the output of that wind farm, like depending on different conditions, which typically differs from like what the manufacturer might tell you, and make sure that that like you know how to like integrate that mix of renewable within like your energy mix. What becomes interesting beyond kind of like one application or like a few applications for like each of those different aspects of the value chain is how do we combine everything, right? So at C3 AI, we actually have looked at those problems like across the value chain, which allows us to now have a very interesting aspects, right? Where like, because we know the consumption of the customer operations, depending on your geography, that might be legally possible or not. But like, if you can actually like operate between the two, you can know that like the customer consumption is going to drive like certain amount of consumption that needs to be balanced by a generation, right? So if we can forecast what is the response of the system to different type of outside variables such as like weather, extra, like we can actually like inform the generation so they can like make their plan correctly. And inversely, like, which is more what happens, the generation being like fixed or known, like how do we maybe like launch challenges? And that's something that we do with one of our utilities. How do we launch a challenge to like through the portal, the energy portal, for the customers in such a way that like they might be incentivized to reduce their energy consumption on like peak days, right? So like winter is coming, like people are going to turn on their heaters. Like, is there something that like that can be done through one part of the value chain, such a way that like the other parts of the value chain is benefits from it. Okay. And then like that led basically to the creation of a series of applications that we have developed over the past, again, like 14 years. C3 AI reliability, we talked about like circuit breaker, recloser, substations, extra, like those are served by a very interesting app called C3 AI reliability that looks at like how those different assets are operating, kind of like what we can say about their current operations, kind of like what are signals of imminent failure, and how can we predict and possibly prevent those failures. And if we cannot prevent them, make sure that at least the team is on the ground, like ready to fix that issue and like with the right assets in their truck to be able to like fix the failing asset. On the energy management side, sorry, we have been looking at both like small individual customers, small and medium businesses, as well as large customers with like their unique needs, right? So like on the large customer side, our solution, which is like, as I was mentioning, like the first one we actually developed, we are able to like help very large companies that have like big energy needs to understand what their consumption is, to be able to like monitor their energy efficiency plans, make sure that like they can justify to their CFOs or their boards like the investment that were made in terms of like energy efficiency, and eventually like drive their consumption down. And as a utility, the dependent of like the customer relationship is a CRM. So through C3 AI CRM, we're able to like help account manager and like salespeople serve their large customers or like their smaller like municipalities and others to use energy better and like know kind of like who is the next person that they should be calling extra. So those are a series of applications that like we have built on top of the C3 AI platform that serve like those different points in the value chain, as well as like, as I said, like able to combine different pieces. The C3 Generative AI, because that's what we are talking about today, is basically an extra layer on top of that. Okay, so it does not replace those applications, it enhances them and gives the ability for a user to ask questions in natural language in such a way that like we can then behind the scene retrieve the unstructured data, like the text and others, retrieve the structured data, the content that is in the OMS system or the MDMS or like the different systems that are available, and formulate an answer that is actually going to like help the user, even if that user is not familiar with like the underlying application, right? So as a user, I can ask like, what are my assets that are most likely to fail? And instead of having to like navigate through the C3 AI reliability products, I can actually like get the same answers through a natural language interface. C3 AI, like through all of the work that we have done with utility, has been able to develop and unlock quite a lot of value that has been recognized by different analysts. So for example, IDC here in 2022, I believe, has awarded Con Edison and C3 AI with like one of their awards, Best in Future of Intelligence North America Awards. The idea there is that the work that we have done with them and this document actually allows us to understand a little bit the scale, has been able to like enable Con-Ed's enterprise data analytics platform to realize an estimated $48.4 million per year in operational benefits. Okay, so like very interesting like benefit for Con Edison, but also like we can understand a little bit the scale, right? So we have integrated 27 enterprise source system, looking at like 800 billion new rows of data per year, 2.2 billion per day, 4.7 million electric meters that we need to keep track of, right? Like those AMI that I was talking about before. And then overall like 20 terabytes of enterprise data, growing at 1 to 2 terabytes per year. Okay, this is one example among like many that like we have in the utility space. And this type of like millions of sensors and like terabytes, even petabytes of data is something that like we are doing quite a lot with the utilities across the world. I've selected like a few utilities that like we actually do business with because like I think they cover like different aspects. So NG like covers like the entire value chain, all right? So we have like some applications with them as it relates to engagement with customers. We have like some work with them as it relates to renewable energy. And this massive utility based out of France is actually like using the C3 AI platform to develop some of their applications themselves. Con Edison, massive utility in the northeast of the US, basically operating like the New York City area. I believe they have like 3 million or so customers. They mostly focus on the distribution side with a massive underground and overground network that needs to be operated, right? So a lot of topics around like AMI ops, etc., that we are doing with them. And then like finally, Duke Energy, big utility, massive utility actually, like in the southeast eastern part of the US. I think they have like 50 gigawatts of produced energy, of installed energy. I think that they have installed power. I think that they have like, it's also like million customers also. So like it's a very big utility with whom we look at predictive maintenance across like their substation, distribution lines, transmissions, etc., in such a way that like they can deliver the energy that they produce to their customers. Okay, so a series of utilities that we do business with. Now, as it relates to generative AI, how do we actually like help those same utilities? Well, we have developed an application, and here is the user interface basically that like we can see that they have access to. So at the top, you can see a search bar. That search bar allows you to ask a question in natural language. So for example, which low voltage transformer in this region is currently overloaded? At the bottom, I have like immediately a summary. Okay, that summary, as I explained earlier, has been looking at like unstructured data, structured data that can be like coming from like a multitude of different source systems. The source systems then like return the data. The system, the generative AI system, decides whether that information is sufficient to answer the question of the user, and then like sends that back to the front ends for display. When we get the results, like in this case, a grid of different transformers that are in low voltage, we can represent that data in different ways, such as like this grid, but also because most likely this data has a longitude and latitude of where the transformer is, we're able to like see it as a map, and the user can then navigate and like identify where the problem might be on the map. We have a series of sources that allow us to understand where this information comes from in such a way that the user is convinced that like this information is not hallucinated by the model. That means like just completely imagined by the model, but that indeed it's anchored in real documents, real sources of data that like the user has access to. We have just below a series of ranked results, okay, corresponding to this other interesting documents or applications or like third-party websites that are useful to the user, even if they were not necessarily used for the summary, right? So, for example, this type of questions regarding transformers yielded a response from the system to link to the AMI one pages of the AMI ops that is installed at that customer, as well as a series of other documents such as PDF, Excel, etc., corresponding to the grid hierarchy, the weather data, etc., as well as like third-party systems that the user might find interesting to navigate to get follow-up answers. Speaking about follow-up questions and answers, we have a chat on the right part of the screen. That chat allows basically an interactive follow-up, like a discussion between the user and the system to be able to say like, hey, based on that question that I asked regarding low voltage transformers, what more can you tell me, right? So you identified like one of those transformers. I would like to like dive a little bit deeper. So the question here is, what was the load distribution for XFMR 72, 74, 98 over the last week, and how many EV chargers are associated? The system emits a new query, keeping in context the original question and answer that were given, and then like identifies basically like the transformer, identify like how to look at the load distribution, and displays that as a grid, but also in this case as a graph, time series graph that the user can look at, always along with like the sources of data. So there's no question about like the validity of those results. I now would like to speak a little bit more about C3 Generative AI in general. What I'm going to say applies to C3 Generative AI for utilities, and we'll discuss a little bit like how we adapt the generative AI for specific industries such as utilities. When you look at traditional generative AI, it's a new field, I know, but like there's a traditional way of looking at it, which is that like the whole discussion revolves around like the large language models, those LLMs. The way we look at it is that LLM is only part of the solution. It's a great piece of technology that was like invented by Google, and then like research, and then kind of like OpenAI is basically the big company that comes to mind when like looking at those LLMs. But it is one piece of the puzzle. It actually needs to be combined with like a series of other solutions to actually unlock the value. That's what I would like to double click on. So if you look at like a traditional large language model, you are going to feed it some data. You're going to feed it some text data, HTML, code, like extra, like all of that, as long as it's text, will fit in it. And then like you're going to start like interacting with it. Okay. So the LLM is going to be trained on the data, and then you're going to start interacting with it. That leads to random responses. Okay. The large language model is only responsible for basically creating the next part of your sentence. So you start a sentence and like the model just completes that. So it can be turned by different tricks into like a question answering system, but fundamentally it just like predicts the next word or series of words. But the problem is like if you don't actually control what that model does, you start just by changing a tiny bit the question, you are going to have vastly different answers. And even sometimes if you ask the same question, the model is stochastic. That means it's going to like randomly basically try to generate the next token. And so sometimes it will pick one token, it will pick another, just to give some diversity. It's nice for creativity, but it's bad for like enterprise systems, right? So you get like some random responses. Second is you don't get traceability. When the model learns from the data, it actually forgets the source. It just knows now that like these are standard series of like tokens and words that like can follow each other. But it's very problematic because the answer that like I get back, I have no way of like validating whether it comes from a real document or not. I also don't have access to any idea of like how to control for who can see what parts of which documents, right? So if I am someone that like is in the generation space, I might be able to see like certain geographies, right? Like my wind turbines or my thermal plants in like my nuclear plants in like certain areas, but not in other areas. Or maybe like legally, my distribution team is not allowed to look at like what's happening on the generation side, right? So we need to be able to like separate who can see what. And with a traditional large language model, like training on top of the data, like you actually don't get that, right? Like you cannot kind of limit what the large language model know. One extra problem with not being able to limit what the large language model knows is that you start having information leakage, right? So again, like as soon as the information is in the LLM, there's a chance that like it will just come out as like a completion or like as an answer to a question from the user. Okay, so that's a very big problem, and there's no like real way of like limiting that if you have shown the model the data to the model and expect it to answer questions. Then it's prone to hallucinations. So we discussed hallucinations a little bit before, but like that's a bug basically in LLMs. But it is basically the large language model is by trying to complete is going to start like inventing facts, right? So if it doesn't know something, it's going to start trying to like complete the sentence to be nice and answer your question, but it might be completely wrong. And finally, like all of the work that you might have done and training an LLM can be like a pretty expensive operation. Basically configuring your system around it is also like an expensive operation. All of that is very LLM specific, right? So you are stuck basically with one vendor of LLM. And if you look at like how things have evolved over like just a year, there has been like tens of different new LLMs and like thousands, hundreds of thousands, if you actually like look at like all of the variations, fine tuning, like modifications of those LLMs that might that have appeared, right? So kind of like placing all of your bets into like a single LLM is like a pretty risky operation. On the contrary, what we do is known in the industry as like retrieval augmented generation, okay? And we have taken that concept to like whole new level. But what does, like, let's parse this expression, retriever augmented generation, right? So there is a retriever, which is basically another system or model that like looks at a series of data and then like informs the LLM of like what is the right data for this LLM to look at in such a way that like it can answer the question from the user, right? It can complete the query. And that separation between the LLM responsible for basically understanding the user query and generating a summary at the end for the user, and the actual memory of the system, like where the data is and like who can access what, extra, actually like enables us to really like address the issues that like we listed before, right? So we get deterministic responses. The reason for that is we actually like modified a little bit the LLM, but we also like make sure that the information that comes back is anchored in the truth, right? Like it's data that comes from like text, HTML, and code, but we know which of those documents we are looking at. But it also comes from like additional information, right? Like now that we have separated the LLM from the retriever, this retriever is able to like connect to structured data such as tables, apps, sensor data, right? Like my AMI system and like all of the smart meter information, or like all of the phase measuring devices that like I can have on my network, or like the substation kind of like sensors that I might have. All of that data is now accessible because I have like a retriever that is able to make a query to get the result. I can also have maintenance logs, okay, that might have been written by a user or by a system that I can start looking at. So the retriever system is able to access this data, is able to remember, like it knows kind of like which of those documents, which of those tables was used and was retrieved, and then sends that all of that information to the LLM. So that addresses like the deterministic responses. Like we anchor like all of the responses into like a known set of documents. Okay, when the query comes, a certain number of documents come back, and therefore like the response that we get is deterministic. We have traceable, like we talked about that at length, but like we know which document the information comes from. We have the ability, like between the time like the LLM asks for the data and the time like the data comes back, we can enforce like that ACL control in the middle. So we know like who made the query, and therefore like we know like what pieces of information that user is allowed to see, right? Like in the C3 AI platform, like every single row of data is actually ACL enabled. So we know like who can see that piece of data and who cannot. So as a user, if I ask a question, the system is going to like go search for information, look at only the information that like I'm allowed to see, and then give me back an answer. Okay, so there's no like, oh, there's an answer, but I'm not like telling you, which would be like basically like leaking information, right? So we're able to enforce like enterprise access control. We're also able to like completely limit data leakage because we don't actually like send the data, the raw data to the LLM. So the LLM is not aware of like your entire database. It only sees data in transit. Okay. To push that even further, we have our own set of LLMs, right? Like we not only do we use like Azure OpenAI, GCP Palm, or like AWS Bedrock, and like through AWS Bedrock, like Anthropic Claude, for example. We also have fine-tuned our own LLMs for specific industries, right? Including utilities and specific tasks like question answering, summarization, code generation, like visualizations, like all of those. So that combination of like controlling the LLM and making sure that like the information that flows through the LLM is really just data in transit and not like the entire access to the entire box of documents allows us to basically prevent data leakage. We are hallucination free, or like we limit vastly the hallucinations by again like anchoring the system in like specific documents that come back. So the LLM is never like left to its own device to like try to make up an answer to a question. It's always basing that answer on documents that will have been provided to it. And it's even instructed beyond that to say that like if it doesn't have documents or like not enough context that comes back, to say I don't know. Okay, so a series of questions will be answered I don't know because like the system doesn't have enough information. Note that I don't know might also appear if as a user I'm not allowed to access a certain piece of information, right? So like that all kind of ties together. And finally, like this solution is LLM agnostic. Like we're actually able to like combine, as I said, like not only like use different LLMs to do the task that I have highlighted here, but also like combine different LLMs for different like pieces of the question. So the LLM that like organizes the work of like looking across like different systems, extra, might not be the same as like the LLM that like does the summarization. So that gives us like much more flexibility and allows us to like pick best in class for all of the different tasks that like we ask this system to do. Okay, so that really gives us like a pretty unique look at like how to solve this problem, and like that has been pushed to production to like multiple customers like at this point in time. So it means that like we're well beyond like a simple like POC or pilot. Like right now we are like actually in production with some customers. I would like to talk about a little use case here.
Energy commodity traders are tasked with buying, selling, and trading commodities such as crude oil, natural gas, electricity, coal, and refined products. Their primary goal is to generate profits by capitalizing on price fluctuations, supply-demand imbalances, and market trends within the energy sector. However, scanning through a diverse scope of information and sources to quickly understand how global market conditions are evolving is challenging. C3 Generative AI for Financial Services is a unified knowledge source that accelerates time to insight for financial services professionals. Users can ask questions in natural language and securely access accurate answers across disparate sources of enterprise and external information. Alex is an experienced energy trader at a large hedge fund. He focuses on trading crude oil globally across both local and foreign exchanges. Alex starts his day by reviewing new developments in global energy markets. Typically, Alex must review several sources, including industry reports, market commentary, news, commodity prices, and emails from analysts to gather the necessary information. With C3 Generative AI for Financial Services, Alex can perform a simple, natural language search to ask about recent developments on crude oil that have been published in the last 12 hours. C3 Generative AI surfaces information about a recent unplanned shutdown at Indonesia's Cilacap refinery and a recent OPEC announcement regarding plans to cut production by 2 million barrels per day. He wants to learn more about the unplanned shutdown and asks a follow-up question. The chat provides a direct answer, maintaining context from the original question. Alex can view the source documents, such as emails and news articles, and investigate where the answer is coming from. C3 Generative AI for Financial Services provides hallucination-free and accurate answers with full traceability to the source. Next, Alex wants to contextualize the search results with information about the refinery operations. He learns that typically 348,000 barrels are consumed per day across both Minas and Duri-grade crude. He also realizes that a significant amount of total Minas-grade crude from Indonesia is consumed by the facility experiencing an unplanned shutdown, which will likely affect the price of Minas-grade crude oil. To confirm his inclination, Alex wants to check the pattern of Minas crude versus Brent crude, which is more widely produced during and after the last shutdowns. C3 Generative AI for Financial Services surfaces that the price of Minas crude dropped by over 10%, while the price of Brent crude held steady. Alex now pivots to understanding the historical impact of OPEC production cuts to understand how this affected the price of Minas and Brent crude. He sees that the last OPEC cut happened on October 5th of 2022 and wants to understand the price impact of this news. Alex can see that following the last production cut, prices gradually increased by over 20% in the 2 weeks following the OPEC announcement. Equipped with the historical impact of similar events on the price of menace and crude oil, Alex has a 360-degree view of the markets before he starts his day. To conclude, Alex shares his feedback with C3 Generative AI for financial services to help continuously improve model performance. With C3 Generative AI for financial services, Alex can quickly access critical information and accelerate his trading decisions, saving hours of time. Visit C3AI/Generative AI to learn more.
So that was an interesting use case on like the trading and sourcing of in this case like crude oil for it was like for financial industry, but really like that's the same use case that like the same use case for the utilities. And so I thought that like that was an interesting video to share. I would like to now like talk about a different case study, something as it relates to AMI ops. So in this case, we're trying to like improve outage report accuracy for utility company, right? So yeah, we have a legacy mapping process on the electric assets, grid assets that produce inaccurate outage reports, resulting in an increased work packages and costs. So basically, like the meters are not placed in the right location, and basically, then because they don't know, like they end up having to search for them, so that like there's higher costs related to identifying kind of like where that meter is, making sure that like we send the crew to the right place extra, and not having problems when the crews are on the ground. If we look at the system like as it is today, basically there's an operation analyst that has access to a set of different systems, and the complexity comes from the fact that like those systems are disparate and typically in very different formats. So the AMI meter would typically come from like a meter data management system or MDMS. It will also the operation analyst also needs to start looking at the grid hierarchy, which is going to be like a file somewhere describing kind of like how like those different assets are connected to one another with some structure. The grid mapping backlog is also like typically an Excel document with like just like how the grid is configured at that point in time, but like that backlog can be like months or years behind. And then finally, like on the they also need to start looking at the outage management system or OMS, which is something that like utilities have to keep track of, right, for regulatory reasons. And so the analyst is basically facing like this like multiplicity of different data sources, and yet would like to be able to perform their job. With C3 Generative AI, we basically have integrated like all of those sources, right? So the OMS, the different like documents in their various shapes and forms, as well as like the MDMS. For the last one, maybe for the first one also, we have virtualized the data. So that means like we don't have to like necessarily ingest it. We can just sit on the existing database that contains like this type of information. And then the user is able to like ask a series of questions, right? So for example, like which meters are associated with like this specific transformer, right? So the system is actually going to then interrogate the system for like try to understand like whether that query is best understood by looking at text or looking at like another source system, and then kind of routing that query to the right place, getting the information, and then like presenting an analysis to the user. You can also ask questions such as which meter has is potentially misplaced, is not actually like in the right location. So we can start like running some ML models and compare kind of like where that meter is with like where it should be according to the record, and see if like that's something that we can give back to the operation analyst. Which transformer is this meter actually like mapped to? When was work last performed on a meter? what is the rating of this transformer, or like questions related to what is the load curve of a given transformer. So so as we look at like this distribution problem, for example, we start seeing that like the operation analyst armed with C3 Generative AI is able to ask a series of like key questions to be able to do their job without actually having to like go and manually find like the information in different places. Note also that like the questions that I asked here are not necessarily questions that like would have necessarily come to mind when we defined a product, right? So we want to have this flexibility and this diversity in type of questions that the user can ask, because like the problems are going to change as we move forward, right? Like what we can solve today, tomorrow, like there will be a new set of challenges. So we want to make sure that like the generative AI solution that we put in place is able, by being generic enough, is able to like answer like set of questions and not like all of the questions from the user and not like a predefined set. If we look at like how we actually accomplish that, we typically go through a 12-week, what we call pilot, and that allows us to basically ingest all of the data that can be like, in this example, like 1 year of data from the OMS system, monthly data as it relates to the grid mapping backlog, the grid hierarchy, so we and the latest one, so we understand kind of like the network as operated, and then like the like access to like also all of the AMI data, or in this case like 100,000 meters that like we place in scope, right? So something that like is going to be slightly smaller than like the full deployment, but that allows us to like basically set the system and make sure that like in 12 weeks, like this application is in the hands of the customer in production, and the user is able to like just crank up the compute, absorb the rest, and like continue the journey like with this application, right? So that's the way we start one of those pilots, and that works very well. Why does it work well? Is because we actually like accelerate the deployment of those pilots through our secret sauce, right? So we have like this C3 AI platform that has in it like basically like all of those different applications and like those connectors to like source systems extra that constitute as a whole basically a domain model or domain models actually for utilities, right? So for each part of the value chain, like we actually have already done integrations with the key source systems. We have already configured basically accessors for those and like representation of those in such a way that like if I talk about a transformer, or if I talk about a plant, or if I talk about a recloser, substation, extra, I have actually like a representation of this in my system. And so like the model is able, the generative AI is able to like tap into any of those and like do its work, right? Like it doesn't have to like be custom built every time like we go to a utility, right? So like that's how we achieve like this very fast path to production. To conclude my section, and before we switch to a demo, I just want to like basically just remind you that like we are looking at like the entire value chain, right? So from customer like management, customer like satisfaction, to transmissions and distribution, and like generation. And as we do that, there's a series of use cases that basically like become apparent, right? Operational efficiency, for example. So like the ability for a user to be able to ask a question regarding like, how do I change this asset? How do I like, what do I need to pay attention to extra? Meter operations, like how do I make sure that like I have an idea of like how the meter operates, like how can I troubleshoot it? Like, is this meter even like problematic extra? So I can start asking questions in natural language. Regulatory management. So I have a series of like things that I need to be compliant. Like that's actually like a pretty big purpose of the utilities, is to talk to the stakeholders and make sure that like they stay within and they justify like the operations that they are conducting. And then like, how do we do that? So like we can give like the legal team a tool to be able to like search through the different document and make sure that like whatever they are doing is in adequation with those laws and regulation. And finally, on the customer operation, the ability to like present the users, so like we go outside of the utility and let the user basically ask natural language question regarding their consumption of am I out of power right now, or like this type of things, right? So that's generative AI actually like allows to to unlock tremendous value by like helping the utility inside to operate better, as well as like offering to their customer or their support team like the tools that they need to understand the data better. Significant time savings, higher productivity and quality, and finally enhanced customer satisfaction. That's what we are after. So that concludes my section on kind of like how C3 AI looks at the utilities, and like how C3 Generative AI kind of allows us to like offer like net new ways to like unlock the value of the data for utilities. I would like to hand over the mic now to Michael Haynes, my colleague and product manager for C3 AI Generative AI. Michael.
Thank you, Louis. Hi, I'm Michael, product manager for C3 Generative AI, and I'm going to quickly show a demonstration of C3 Generative AI in a notional example of a utility that operates wind turbines. And the use case is from the perspective of maintenance and operations of the wind farm. So the first question that a maintenance worker might want to know is, how might a wind turbine fail? So in C3 Generative AI, we've provided access to the application to service manuals, troubleshooting guides, maintenance manuals, and other documents about the maintenance process for these wind turbines. And we can see that the system was able to traverse through those documents and summarize an answer in natural language to answer the natural language query asked by the user. You can see the question that was asked, how might a wind turbine fail? We see a wind turbine can fail due to abnormal readings, grid failure, flash fail, or other minor malfunctions and electrical faults. So we have the answer to the question, and we also have the rationale for how the system arrived at the answer that it arrived at, as well as citations to the sources that were used to create this answer. So I can hover over this source, which is a Siemens service manual, and this shows me the specific excerpt from that large document. This is a 900-page document that contains the information that was used to answer the question. I also can open the original source document right from here in a new tab to take me to the page within that large document where the information came from, so that I can explore further more information within that document. And you can see that this answer was actually sourced across multiple documents, this wind turbine troubleshooting guide as well. On the right-hand side, we see a follow-up chat component where I can ask further questions. So I can ask the question, what might cause an electrical issue? And so I can further engage with the system in my troubleshooting workflow to ask now about electrical faults more specifically, which were one of the failure modes for a wind turbine. I also see from the original question other relevant documents that might come back. In this case, these were the two documents that were used to answer the question. But so as the system answers the question, I can see that assessing the condition of critical electrical components like transformers, rectifiers, and inverters for signs of damage or failure, utilizing a multimeter to measure the voltage and current output of the generator, and checking the alarm logs for any relevant information may cause an electrical issue with the wind turbine. So I can see again that I see the citations to the sources. I can give feedback to the answer if I think that this was a helpful answer. So I can say this and give more direct feedback to capture my interaction with the systems. I can also ask questions about kind of the sensor readings that come off of these wind turbines. So I might be curious about the gear oil temperature for one of my wind turbines. So I can say, what was the average daily gear oil temperature for turbine 1 in May? So if you think about what this question is asking, so this is no longer a question that can just be answered with unstructured maintenance documents and troubleshooting guides. This is actually looking for historical sensor measurements that are coming off of this specific turbine, turbine 1, and you can see that the data was fetched from a structured data source from a time series database, and presented over the relevant window of time. So we can see that the information was fetched from May 1st through the end of May, and we can plot as a time series the gear oil temperature average daily readings over time, and you can see these oscillations over time. We also see that the answer that I asked, what was the average daily gear oil temperature, the language model was able to summarize that information across the interval, giving us summary statistics such as the average, the minimum, and the maximum. And so this is kind of a unique feature of C3 Generative AI, this ability to blend retrieval across both structured data sources as well as unstructured data sources, and kind of provide this higher level workflow to the end user that really allows them to accomplish their task at hand. So with that, I will give it back to Kwok An to close us out for the day.
Thank you, Luis and Michael, for the great presentation and demo. For our audience, please continue to submit your question using the Q&A window. So now we will get started with a few questions that already came in. The first question is for Luis. How does C3 Generative AI understand and incorporate utility-specific issues in its responses? How do you train the model on the company and industry context?
Yeah, that's a very good question. What we do is we go through a couple of things. One is the answer that we provide, as I explained earlier, are like anchored in the documents that were provided to us, or that we can actually connect to, right? So through that, we basically do not need to train a specific LLM on the specific data of the customer, which is like nice because again, like we risk like less data leakage and other things, and it's also like less expensive to put this solution in place. But if like in the specific case of like utilities and in industries in general, there might be value in performing like either specific task or to understand like specific like language of that industry. So in the case of utilities, if I talk about like MDMS, if I talk about OMS, etc., I'm expecting the model to know what is going on. And so in that case, what we do is we train the model on a series of documents that include like this type of vocabulary. So we typically do it as part of the product itself. Okay, we don't necessarily do that as part of like a pilot with the customer because we want to have those models that are like ready for the industry, and that allows us to basically deploy quickly, right? But like we feed like a series of documents that contain like those key terms extra in such a way that the model now knows that like when someone talks about MDMS, they really talk about like meters and like AMI and stuff like that. Like all of those terms are like allocated together, and then. Similarly, if I talk about OMS, then I'm talking more about like a transmission problem extra. So like I'm expecting the model to know those things, and like we train our LLMs to be aware of them, right? So that's part of the product. I hope that answers the question.
Yeah, thanks, Luis. The next question is for Michael. What makes C3 Generative AI different from other generative AI vendors like OpenAI?
Thanks for the question. So the question was, what makes C3 Generative AI different? So I would say there are three primary things that make C3 Generative AI different. First is kind of our ability and capabilities of the underlying platform to apply enterprise security to the data that is retrievable through C3 Generative AI. So Louis touched on our kind of architecture using a retrieval augmented generative approach. That with the frameworks of enterprise security that are afforded by the C3 platform, allowing role-based access control and restrictions to row level at the row level to data allow us to make sure that information that is surfaced by C3 Generative AI to an end user is commensurate with the role and the function of that user within an organization. So the framework that we have for implementing that is pretty unique. Second, I would say is some of the future proofing that Louis talked to with the abstraction layer of the C3 AI platform that underlies C3 Generative AI, right? So the ability to, as new language models, as new use cases emerge within your organization, you future-proof the architecture and allow through easy configuration to swap one model in for another, and kind of allowing for easy experimentation as the state of the art develops. And third, and I think most importantly, is to the point that Louis made around our domain models that we have included as part of the C3 platform. That really is a massive accelerator for, especially in like the utility space where we at C3 have well over a decade of experience. We have these pre-built domain models that we can layer C3 Generative AI on top of to really uniquely extract information from both structured and unstructured data sources. Now, without the abstraction layer and without these domain models, an implementation of that would take a much longer time, would be a much more difficult task, not just to build, but also to maintain long term. So kind of for those three reasons, I would say that we kind of are pretty unique in the market and largely differentiated away from the other language model providers, because our solution is so much more than just the language model.
Thank you, Michael. The next question is for Louise. So my company has businesses in generation, transmission and distribution, and supply. Will C3 Generative AI be applicable to all three of my businesses?
So I actually think that I answered that question. So maybe it was asked early on, but yeah, we right, like I covered that in the slide, or like I was showing like the different parts of the value chain, and like how C3 AI as a company and like the set of applications serves like every single piece of that value chain. So like I think that like that's the users like utility or like company will benefit definitely from C3 AI, and will benefit in turn of C3 Generative AI across like the entire value chain, right? Because as a user, I'm able to like, as a consumer of energy, right? So for my consumers, I'm able to offer to them like a way of like asking natural language question to understand their energy better. As like an operator of like the transmission lines or like the MI extra, I'm able to like, that was the use case I'm able to like ask questions regarding the operations of my system, how to fix it extra, which was like the use case I was presenting. And as a generation person, like someone that's responsible for maybe like implanting like a new wind farm somewhere, or like generate like sourcing like fuel for like my different plants, or like trying to understand like the delta between like different plants extra. I have access to C3 Generative AI, so through a natural language interface, ask questions against my data raw, but also through like the machine learning models that are part of like the pre-built C3 application, to be able to make like forecasts, or like to be able to like do some pre-advanced machine learning as it relates to predictive maintenance, or like other use cases, right? So I think that like we really cover like end-to-end the value chain of utilities, and so I think that like yes, absolutely, like get in touch with us.
Thank you, Louise. I think we have time for one last question. How to get started with C3 Generative AI? What is the process to bring it into operation? So Louise and Michael, feel free to jump in.
Yeah, I'll get that one. I'll take that one. So as I mentioned, right, like, so first, like, you should reach out, but like the way we get started typically is we scope a pilot. Pilot is a way for us to get to know each other, and also like to develop in 12 weeks an application that like is going to provide value to your utility, to your company, and so at the end of that pilot, you can decide whether you want to continue with it, or if you want to like switch the use case, or if you want to like do something else. But like that's the way we're going to get started. So how do we get started there? Like we scope pilots, we identify like a set of sources, as I mentioned, that like are like within the realm of the sizes that I mentioned earlier. Something that is tractable, something that most importantly provide value. We are laser focused on value at C3 AI, and so like something that provides value. And then like we, you give us like some subject matter experts, like you indicate like how, where the data is and kind of like how we can work with you. And then like in turn, we're going to put a team in front that is going to like show that like the generative AI solution is implemented to solve your need, and then like hand it over to you. Okay. So during that process, you'll learn about C3, you'll learn about how we work, you'll learn about the different aspects of generative AI. You'll learn how to like also be autonomous. We are a software company. We are not like a services company. So we want to make sure that like you're autonomous, like after with the solution, and you can make it evolve, right? So that's a pilot that any of our salespeople can walk you through. I don't know if Michael, you have like other points you wanted to highlight.
Just echo everything you said, Louis. The pilot program with the focus on value. I mean, that's what we're all about. So.
Cool. Back to you, okay.
Yeah, thank you so much. I think that's all we have for today. As a quick reminder, this webinar will be available on demand, and you will receive an email with the link later today. If you enjoyed today's content, please follow C3 AI on LinkedIn, Twitter, and YouTube. We'll be hosting more webinars on generative AI and utilities in the near future. Thank you again for joining us, and have a great rest of your day.